right fraction in lowest terms. We mean equivalent fractions in lowest terms, aka also known as simplify. And for simplicity's sake, let's just call it simplify from this point going forward, but be aware, be known. You can't say we didn't tell you. It's also known as right equivalent fractions in lowest terms, also better known as right fractions in lowest terms. 2, we must simplify to the smallest numerator, which is the number on top, and denominator, which is the number on bottom. That's just an example, 2/4. Possible. Simplify to the smallest numerator and denominator possible. Is that the smallest numerator and denominator that we can use to represent 2/4? Or is there something else? Let's simplify. 2/4. If you divide 2/4 by 1, what do you get? That's like something times 1 is 2/4, right? What do you multiply by 1 to end up with 2/4? 2/4! 2/4 times 1 is 2/4. It's like a mirror reflection, right? Well, what if we take that and just consider the following, that we put the fraction 2/2 in here. It's funny, we call 2/4 2/3, but we don't say 2/2. But all I want for Christmas is my 2 front teeth. No, 2/2. 2 teeths? Anyway, why can we do this? But first of all, I want to show you how that's 1. Because if you have 1/2, and 2/2, or 1 tooth and 2 tooths, you can actually combine them together, and you get, of course, 1. So that's how that works, right? Anytime you have the numerator is the same as the denominator, that's equal to 1. All right, so we're going to divide. Now notice, we're dividing the top by the bottom, but we're really dividing by 1. Okay, just so this makes sense here. Hopefully, 2 divided by 2, right? 2 divided by 2 is 1. 4 divided by 2 is 2. 1/2. There it is. Again, even though the numbers in 1/2 here are smaller than the fractions over here in 2/4, they are still equivalent. They're the same. See? Simplify. Here we go. I'll show you. You don't believe me? Of course you do. Boom. Take that 1/2. Bring it over to 2/4. They're the same. Now, let's try this. 3/9. I'm going to demonstrate for you. How can we write our final answer here? 3/9. Let's see. 3/9 divided by what form of 1? Can we divide 3/9 by? Something that 3 and 9 is a common what? Factor. That's right. What's a common factor of 3 and 9? I know. 3/3. 3, because 3 divided by 3 is 1, and 9 divided by 3 is 3. You can check that. You can go 1 times 3 is 3. 3 times 3 is 9. Now, can we do it anymore? Can we bring it down anymore? Can we divide by 1? No. That's it. They're both prime numbers. You're done. And just to be clear, 3/9 is equivalent to 1/3. Just because that 1 and 3 look like they're smaller numbers, it's still equal to 3/9. See? Oh, boom. 3/9, 1/3. 3/9, 1/3. 3/9, 1/3. 3/9, 1/3. Boom. 3/9 is equivalent to 1/3. I'm going to try one more, and then it's going to be your turn, so get ready, everybody. Let's try this one, 30/45. I know a factor of 30 and 45. Since this ends in a 0, this ends in 5. 5 will go into both of these. So I'm going to divide by 5/5, which is the same thing as 1. So 30 divided by 5 is 5, 10, 15, 20, 25, 30. That would be 6. 45 divided by 5 is 5, 10, 15, 20, 25, 30, 35, 48. And you can check it backwards. You can go, well, let's see. 6 times 5 is 30. 8 times 5 is 45. Now can we reduce this? Can we simplify this anymore? Can we we did make the numerator and the denominator the smaller numbers, but are these the smallest numbers possible to represent this same fraction, this equivalent fraction? Can we divide by, I know, they're both even numbers. We can divide this by 2 and this by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Dun, dun, dun. There it is. You can check it backwards. 4 times... Oh, I put it in the wrong place. Pardon. I beg your pardon. It's not equal to 1. This goes here. There we go. Now I can check it backwards. 3 times 2 is 6. 4 times 2 is 8. And we are greatly done. Your turn.